Hello class and welcome to section 8.6. This is our day 2 of solving rational equations. Okay, so just recall from our last notes video that a rational equation is any equation that contains one or more rational expressions. So remember, to be rational means that it's written as a fraction, so it has to have one or more expression that is written as a fraction. So some examples, or one example would be 2x plus 3 is equal to 5 over 2x. That is one example. Another example might be 2x plus 1 over x minus 1 is equal to x over x minus 1 squared. Okay, that is some examples of some rational equations. Today we're going to be solving rational equations. And so when we're solving rational equations that we're looking at today, there might be what's called an extraneous solution. And an extraneous solution is when a solution is not a solution of the original equation. Okay, so when it is not a solution of the original equation. So say I would get, for instance, in my example up top here, say that I get x is equal to 1. Well, if I plug in 1 to my denominator, 1 minus 1 is 0. And you cannot divide by 0. So then this would not be a solution. That's what we would consider an extraneous solution. Okay, so let's look at the rational equations that we have today. Today they're a bit different in the respect that you're going to have to do some factoring before we go ahead and find our common denominator. So let's just go ahead and look at 1. Okay, so if I'm looking at 1, I would factor this first piece, r squared minus 1. So I'm just going to rewrite, I would have r over, and I would have r squared minus 5, and then it would be r plus 1, r minus 1 is equal to, and now I would have r squared plus r plus 2 all over r plus 1. Okay, now I can look at this and I can easily see what my least common denominator would be. Okay, before it was maybe a little hard. So today you're going to have to do a little factoring before you find your least common denominator. So my least common denominator, it's going to have an r plus 1. I can make them all have an r plus 1. So r plus 1, and I need to add an r minus 1. Okay, so then the same thing as yesterday, I'm going to multiply all my numerators by that LCD. So I would have r times, okay, really quickly, r plus 1, r minus 1. It's the same as r squared minus 1. So since there's nothing in my denominator that will cancel, I'm going to actually write this as, okay, or I'm going to write it as r squared minus 1. Okay, so it's r times, this is an or, r squared minus 1 plus, okay, now I would have what I have here, r squared minus 5. Then I would have r plus 1, r minus 1 all over my r plus 1, r minus 1 will equal r plus 1, r minus 1, and then I would still have my r squared plus r plus 2, run out of room a little bit there, all over r plus 1. Then I can go ahead and do my canceling. Okay, r plus 1s, those will cancel here, and they're going to cancel here, and the r minus 1. So now all my denominators are gone. Now I'm just going to distribute and solve. Okay, so this would give me r to the third minus r plus r squared minus 5 is equal to, all right, I'm going to rewrite the right hand side, and then I'm going to go ahead and start simplifying. So we have r minus 1, and then it's r squared plus r plus 2. Okay, so on my left-hand side, I'm going to rewrite it in standard form. Just remember, standard form is writing it with the highest exponent to the lowest exponent. Okay, there is no like terms to combine there. And then on the right-hand side, I am going to distribute to each one. Okay, so I would have r to the third plus r squared plus 2r. Now, minus r squared minus r minus 2. Now I need to go ahead, combine my like terms on the right-hand side. So I'd have r to the third on the left. So I'm just rewriting the left-hand side. Now I'm going to combine my like terms. I have r squared and negative r squared. So those will cancel each other out. Then it looks like I'm left with, I have 1r to the third. So r to the third, 2r minus r. So that's going to give me r minus 2. Okay, then the last thing I need to do is solve this. Okay, I would notice that if I subtract r to the third from both sides, there is no more r to the third. I notice I will have an r squared, so that makes this a quadratic. So remember, to solve a quadratic, you have to get everything onto one side. So I'm going to move everything to the side where my r squared is. So I'm going to subtract this r and add 2. So I have r squared minus 2r minus 3 will equal 0. Now I just need to factor. So it multiplies to negative 3 but adds to negative 2, negative 3 and positive 1. So if I solve this, I get r is equal to 3. If I solve this, I get r is equal to negative 1. So now here's where I need to check for my extraneous solution. So notice how this is r plus 1. If I plug in negative 1 here, it will give me 0 in the denominator. So this one is not a solution. I do not write it down. This is what we call as our extraneous solution. Okay, so we do not write that one down. The only answer I would do is write down r equals 3. Make sure you always plug your answer in here and check to make sure it works. That's the way to ensure that you have the right answer on your quiz. Okay, all right. Let's look at example 2. Okay, same thing here. We need to go ahead and factor if we can. This is r plus 2. This is, sorry, x plus 2. This is x minus 1. This one I can write as x plus 1, x minus 1. Using our difference of perfect squares. And so my least common denominator, what could I make all of my denominators be? Okay, well, I could make them all have an x plus 1 and an x minus 1. So my least common denominator is x plus 1, x minus 1. Or I can remember that's the same as x squared minus 1. So let's go ahead and distribute. Okay, I would have 2 times x plus 1, x minus 1, all over x plus 1, minus, it'd be 1 times x plus 1, x minus 1, all over x minus 1, equals, in this case I'm going to use the x squared minus 1 because you see how the denominator here was written as x squared minus 1. So it's negative 2 times x squared minus 1, all over x squared minus 1. Now let's do my canceling. X plus 1s, x minus 1s, x squared minus 1s. Okay, good. Now I'm going to distribute. So I would have 2x minus 2. Now the next thing is, notice it's a negative. So I have to distribute this negative 1. So it's really minus x minus 1 is equal to negative 2. On the left-hand side, I'm going to combine like terms. This will give me x minus 3 is equal to negative 2. Add 3 to both sides. So I will get that x is equal to 1. Now I go ahead and I plug in 1. If I look here, I have 1, and 1 minus 1 will give me 0, so I will have a 0 in the denominator. So since that happens, it's an extraneous solution, so I do not write that one down. I would actually just say that there is a no solution for this problem. Okay. If you have any questions, please make sure you write them down. Otherwise, we're going to move on to example 3. Okay, looking at example 3, we need to go ahead and factor the denominator. First one I can factor out of 3, so I have m plus 1. The next one I can factor out of 4, so I have n minus 1. So 4 times n minus 1. And the last one, I can factor out a 2, so I would have n plus 1. Okay, so in this case, for all of them, I have an n plus 1, an n minus 1, and an n plus 1. So I for sure have n plus 1 and n minus 1. Now I need to look at my numbers. I have 3, 4, and 2. So I need to decide what can I make 3, 4, and 2. What can I multiply all of them to be? Well, I think 12 would be what I could make them all be. So I would multiply all of them to 12. So I would have 12. Okay, so it's 12, n plus 1, n minus 1. I'm going to go ahead and distribute that, taking it to the numerators. So I would have 7n times 12 times n plus 1, n minus 1, all over 3 n plus 1 minus 5 times 12 times n plus 1 n minus 1 all over 4 n minus 1 is equal to, so I might get a little crowded, so I might have to write it sideways. So we have 3n times 12 times n plus 1 times n minus 1 all over my 2n plus 1. Okay, sorry, parentheses, 2n plus 1. Now let's go ahead and cancel what I can. Okay, 12 is divisible by 3, so this gives me 4. N plus 1s, those will cancel. 4 divided by 12 will give me 3. N minus 1s will cancel. 12 divided by 2 gives me 6, and then we have n plus 1s. So let's write down what I have now. 7 times 4 is 28. So I have 28n times n minus 1. 5 times 3 is 15, so minus 15 times n plus 1 is equal to 3 times 6 is 18 n, and then I would have my n minus 1 still. Now I'm going to go ahead and distribute and start solving. So I would have 28n squared minus 28n minus 15n minus 15 is equal to 18n squared minus 18n. On my left-hand side, I'm going to go ahead and combine like terms. So I have 28n squared, negative 28 minus 15n will give me negative 43n. Minus 15 is equal to 18n squared minus 18n. Okay, I would notice that this is a quadratic. Okay, my n squareds are not going to cancel each other out, so they're going to stay there. So I would need to go ahead and move everything to one side in order to solve this. Okay, so see that I have a larger n squared over here, so I'm going to minus 18n squared from the right-hand side and the left-hand side, and add 18n. So 28n minus 18n will give me 10n squared. Negative 43n plus 18n will give me minus negative 25n. And then minus 15 is equal to 0. Okay. Now this one I need to factor. Maybe one thing I notice is that they're all divisible by 5. So maybe first I would take the time and factor out a 5. So I'd have 5. So I would have 2n squared minus 5n minus 3 is equal to 0. Now I would go ahead and factor I know that to get to 2n squared, I have 2n and n. Now I would think of my multiples of 3. I'm going to try 1 and 3. This gives me n. When I multiply this one gives me 6n. Is there any way using these two numbers I can get to negative 5n? Well, if this one is negative, then I would have negative 5n. So 2n times negative 3 would give me negative 6. So this is positive. So there it is factored. That's kind of guess and check method. If you want to go ahead and do it using grouping, you can. Make sure you can factor that on your own. Then I would set each piece equal to 0. There's no exponent with this 5 here, so we can ignore that. So we're going to have 2n plus 1 equals 0, and n minus 3 is equal to 0. I would subtract 1, so I have 2n is equal to negative 1. Divide by 2, so n is equal to negative 1. Add 3 to both sides, so I have n is equal to 3. Then I would go ahead and look. Oh, sorry, divide by 2 on this one, didn't I say? Then I would go ahead and check if I plug in a negative 1/2, would I have any problems? No, I would not, so n equals negative 1/2. That's one answer. If I plug in 3, would I have any problems? And by problems, I mean it would make 0 in the denominator. No, I do not. So my answer is n equals 1/2 and n equals 3. Okay. All right, we have one more rational equation that needs to be solved here. I would highly recommend that you pause the video and try example 4 on your own. Okay, so please do pause the video and then try example 4 on your own. All right, so we're back. I'm going to walk through example 4. Factor this denominator, so it's p minus 1, p plus 1. So I'm looking at this. My least common denominator would be, this one has a p plus 1, this has a p plus 1. There's nothing under here. So my least common denominator would be p minus 1, p plus 1. I wrote 2. Meant to write 1. Okay, which can be written also as p squared minus 1. Okay, so I'm going to try and save some steps this time. Okay, when I take this and multiply it here, I'm going to have my numerator left. Okay, so that's what my numerator currently is. And I multiply it by this. But does everybody see that the p plus 1s will cancel? So it's really only multiplied by p minus 1. Okay, will equal, if I take this and multiply it, my denominator will cancel. So I am going to be left with what I have in my numerator. Plus, now we're on to this last piece. There is no denominator here, so nothing will cancel. So I'm going to write it as p squared minus 1. So it's p times p squared minus 1. Okay, so now I would distribute just doing this process of distributing. Okay, and so I have on the right hand side p squared minus 7, distribute again, so plus p to the third minus p. Combine my like terms. I have a negative p squared, so I would have p to the third minus 2p squared. P plus p is 2p minus 1 will equal, and I'm going to write the right hand side in standard form. So p to the third plus p squared minus p minus 7. Okay. So now again, I see if I subtract p to the third from both sides, those will cancel. Okay, and now if I see my p squareds, those are not going to cancel. So this is a quadratic, but I'm going to go ahead and add 2p squared to the other side. The reason I'm going to do that is because I like to keep my p squared term positive. If I would have subtracted this p to the other side, that would have made it negative. Okay, so minus 2p. So I'm moving everything to the right-hand side and add 1. So what we are left with is 0 is equal to 3p squared minus 3p minus 6. In this case, I see that I can factor out a 3. And now I will factor. So I would have p, what multiplies to negative 2 but adds to negative 1. Negative 2, positive 1. And I would set each piece equal to 0 and solve. So I would have p minus 2 equals 0, so p will equal 2. If I check that in my denominator, would it make my denominator 0? Well, 2 plus 1 is 3, so that's good. 2 squared is 4, 4 minus 1 is 3, so we're in good shape here. So p equals 2 is one solution. Then my next one, p plus 1 equals 0, so p equals negative 1. Negative 1 plus 1 is 0, so this one's extraneous, so I do not write that one down. You do not write an extraneous solution down on a quiz key, because otherwise you're going to lose a little bit of a point, because that one is not technically a solution. Okay. So we have 2 more examples. So let's go ahead and look at them. Example 5, Brianne and Owen paint houses together. If Brianne can paint a particular house in 6 days and Owen can paint the same house in 5 days, how long would it take the 2 of them if they worked together? Okay, so it says, how long would it take? So we want to know the time that it's going to take them to get the house done. So let's just talk about Brianne for a second so we can get an idea. Brianne can do a house in 6 days. So if she has 12 hours, okay, I'm telling you she has 12 hours. How many houses could she do? Well, I would take 12 divided by 6. So that means she can do 2 houses. If I tell you that she has 18 hours, okay, she can do 18 divided by 6. So she could do 3 houses if they were all exactly the same size. So what if I say she has X hours? Because we don't know the time. Okay, we don't know the time, so I'm going to let that be X. So if she has X hours, it's X divided by 6. That's going to tell you how much of a house she can paint in that many hours. Okay, so this is how Brianna would work. So Brianna can paint a house in X over 6. Okay, so the way we're going to set this up is it's going to be Brianne can work at X over 6 hours. And then the same idea with Owen. Okay, they're working together, so we're going to add it. Owen can paint the house in 5 days. So same idea. If I have 10 hours, 10 divided by 5 will give me 2 houses he could do. So if I have X hours, it's X divided by 5. We'll tell you how much he can get done in the number of hours that they, or sorry, days that they give us. Sorry, this should say days because we're talking about in days, right? Same idea, except for we're talking about in days. So this is Brianne plus Owen. They're working together. This is the rate at which they're going to work. Okay, well, how many houses are they going to do? Well, we want it to equal 1 house. Okay, so this is the setup. You will be seeing this frequently, so make sure you feel comfortable with setting this one up. Now what we need to do is go ahead and find my least common denominator. There's no denominator here, so I would say to myself, 6 and 5. What is the number that I could get 6 and 5 to multiply to be together? Well, 30. So I'm going to take 30 and multiply it by my numerators. So I will have 30x over 6 plus 30x over 5 will equal 1 times 30 is 30. I'm going to simplify. 30 divided by 6 is 5x, plus 30 divided by 5 is 6x, will equal 30. 5x plus 6x is 11x. And then to solve, I would divide both sides by 11. So x will equal 30 over 11. Or I would say that this is 2 and 8/11, and my proper label would be x is the time, and we're talking about in days. Okay, so there is example 5. If you have any questions on example 5, please be sure to ask. All right, one last problem. Example 6, the ratio of 16 more than a number to 16 less than a number is 1 to 3. What is the number? So first thing is ratio. We've already talked about this. It's a fraction. Okay, so the ratio of 16 more than a number. To be 16 more than a number, well, I don't know the number, so it's going to be x plus 16. 2. This tells you where that fraction bar is. Okay, so this is my fraction. To 12 less than that number. To be 12 less than that number, it's going to be x minus 12. Is our keyword for equals. Is 1 to 3, so 1/3. All right, so what we're going to do here is we would say, well, what is my least common denominator? It's going to be 3x minus 12. When I multiply it, I'm going to have 3, and my x minus 12s will cancel, so I'll have x plus 16 is equal to, here, if I multiply this, my 3's will cancel, so I will just be left with x minus 12. Some of you might be like, well, in this situation, you could cross multiply, and you could. This times 1 will give me x minus 12. This times this will give me what I have here. So if you wanted to do that too, you could. Then I would go ahead and distribute. So I would have 3x plus 3 times 16 is 48 equals x minus 12. I would subtract x, and I'm going to subtract 48. So we have that 2x is equal to negative 12 minus 48 is negative 60. I would divide both sides by 2. So I get that x is equal to negative 30. So the number that they have is negative 30. And I would recommend plugging it back in and making sure it's correct. Okay, that will be it for section 8.6 day 2 notes. There's a lot going on here, so please, if you need to, come and ask me questions, write them down now. I just want to make sure that you're asking for help if you need it. So make sure you're coming in. Otherwise, I will talk to you later and have a great day.